Hello, everybody. Welcome to the Stats for the Masses webinar, Research Design, Research Method. What's the difference? My name's Elaine Eisenbeisz. I'm the owner and principal statistician here at Omega Statistics. Thanks to everyone who's taken the time to join us live today. This is actually a favorite webinar for our fans. It's a personal favorite of mine, too. So what we're going to cover today are some the differences between research design and research method. Our last webinar in, I think it was September, was about the literature review. So typically after you get your literature review done, your next question is, well, okay, what am I going to do? How am I going to set this up, right? So that's what we're going to cover today. The well-planned study, it's the only kind of work that's worth doing, right? Working a bit more at the front end of your research, taking the time to think about the logic as well as the logistics of your study will save you time, money, and maybe might even add a few years to your life. Today's just an overview, but I hope that the information you receive today will give you some ideas and guidance on planning your research. I say this in all of our webinars, but use what you learned today, apply it in a holistic way. As a researcher, it's important to look at the big picture, and it's important to take into account what can go right and what can go wrong. There's always limitations in every study, so you want to take those into considerations too, and looking at the big picture will help you to see these things. This presentation is probably going to last about 45-50 minutes. Then we'll take some time at the end to answer some questions. However, I'm going to take some time as I go through the presentation to pause and ask for questions from the audience. So you don't have to wait till the end. So maybe I'll get some help with Rod, who is here today helping me. I've currently muted the line, so only my voice could be heard. But Rod is our board operator, and he's with Silverado Creek Studios. And we have him to thank for helping to get our recordings in top shape before delivery to our viewers. If you call the Omega Statistics offices, he's the voice that you hear on hold, or if you call after hours, he's got that wonderful voice. In fact, local radio station calls him Mr. Golden Honey voice. If you stick around for the Q&A, you'll get to hear what I'm talking about. So in the meantime, though, if you have any questions, feel free to type them on the chat board. And like I said, I'm going to stop every now and then through the presentation, and Rod will ask me any remaining questions we have at the end of the presentation. And yeah, we do have the same last name. It's Rod Eisenbeisz. He's my husband, but he's awesome. He's great. So he's the best. If you have any technical issues, I often find that just logging out and back into the webinar clears up just about everything. So when in doubt, reboot. And let's get started. Everybody sees this slide every webinar, and nothing much has changed. I am a private practice statistical consultant. I'm based in Southern California. I do medical, clinical, biotech research, specialize in clinical trials, all the phases. I do work on methods, and I also work on data analysis. So I do design and analysis. I do help with dissertation assistance. Somebody did type in when they signed up for the webinar, they wanted to know, are you available for hire for PhD students to advise and or contract for research-related support? Yes, I am. That's probably what we do best here at Omega Statistics, is helping the dissertation clients. It's one of my favorites. And then, of course, the clinical research. We also help with survey design, also with the big data kind of things, predictive modeling, exploratory design, things like that. I work on projects just about of any size, from individual researchers working on their journal articles, the dissertation students, small businesses, and then I've worked with large corporations like Amgen. I've done the Lean 13 program for Nutrisystem. I did the analysis on that. So yeah, the nice thing about being a statistician is you can play in everybody's backyard, and that is very true. And our motto is to provide elegant solutions effectively applied. So we'll start with what is research design. We'll start with design, and as we go through this webinar, you're going to see how it kind of just flows right into the methods. So there's not really a stopping point where you stop at design and you go into methods. They are very much related. However, you kind of need to think about the design first. I think I already mentioned that design is logic, methods is the logistics. So the design is the framework, basically what you're building, how you're designing it, as far as the theory and the logic of it. And the methods are your nuts and bolts, your tools that you're going to use to actually get the answers that you're looking for. So the textbook, I always like to show the textbook and then kind of make it a little bit simpler. The textbook definition of research design is it refers to the overall strategy that you choose to integrate the different components of the study in a coherent and logical way, thereby ensuring you will effectively address the research problem. The Stats for the Masses definition, think of design as your recipe. Okay, what are you making? How will it look? Are you making a cake? Are you making a souffle? Are you making a roast? What are you making? What ingredients do you need? How will you cook and serve it? Will it be tasty? Is it going to be good? You can also think of research design as a blueprint for collecting, measuring, and analyzing the data. It's your blueprint. So recipe, blueprint. The research problem is going to determine the type of design you will use, not the other way around. So you do your literature review and you have a good idea now of what your gap is, what the problem is you want to address, and then you're going to design your study around the problem. The best study designs have repeatability, which means that they're laid out in a way that another researcher can read your report, look at your study, and they can reproduce it. Okay, they can run it and see if they can get the same kind of results. So you want to have enough information and detail it enough so that somebody else can come along and try to reproduce your results. Also, generalizability. Not only will the results apply to the population you sampled for your study, but when your study design is repeated with another sample from the same population, the results should be similar. So you want to try to put that into your design. Usually generalizability is going to be mostly with an experimental design. You're not going to see it very much with other designs, and we'll cover it a little bit more as we go through things. I'll talk about it a little bit more later when we get to the experimental design part. But the repeatability or reproducibility and generalizability give more validity and impact to the results of the study. We usually design a study for the repeatability and generalizability. It's a bit harder to come by. Like I said, it only happens by repeating the study over and over. If you don't have an experimental design, basically, if it's a correlational study, something like that, you're not going to get generalizability. The only way you're going to get close to it is to have the study done over and over and over and over again by different people with different samples. Basically, now, it's an overview today, okay? So there's probably many, many designs I'm not going to cover. I'm not even going to mention, but there are basically three types of research designs. There's a descriptive design, and it's basically what it is. It describes the subject or the phenomena with words, numbers, both. Sometimes it's as simple as, here's the means and standard deviations, and here's the counts of how many people we had in each group, and maybe there was some observation done, and it's basically just detailing out what you saw. Descriptive studies, you'll mostly see those in a qualitative type of study, and we'll talk about that in a little bit. But it's basically just a description, not really statistically involved at all, just descriptions. There's correlational. And a correlational study measures the relationship or association between variables. It's basically, we're going to have one we're working on today where the sun rises and a rooster crows. What's the relationship? How are they associated? What's the strength of the association there? Then there's experimental. And like I was saying, that's typically the gold standard. That's if you can do this, this is what you want to do. But most studies, especially if you're working on a dissertation, if you're in the social sciences, if you're in some of the soft sciences, you're not going to really have an experimental. You'll probably have more of a correlational, maybe even descriptives. But experimental is when a researcher will manipulate the subjects to investigate a cause and effect relationship. So if you do something to one group but not another group, does it change the outcome? So a lot of times in clinical research, you'll have a treatment and control group, and you randomize people into each group, and then you run your test, and then you have your experimental design. And it's generalizable because by randomizing, you control for a lot of things, all these extraneous factors that you wouldn't necessarily do with a correlational. Because correlational design, a lot of times when you sample for those, you're not randomizing, you're just taking people as they come. It's a convenient sample. So we'll do sampling another day. So under the three broad classifications we just talked about, there are many more designs that will fit specific research problems or study purposes. And these can often be split into two groups of research design. And actually, qualitative and quantitative, I wouldn't really call them design. I would call them more of a method, but they're more of a method of inquiry. Okay, so how are we going to set up our study? Are we going to ask a lot of questions, or are we going to actually collect some data and crunch some numbers? And that's the big difference between the two. Qualitative designs are often used to address the why questions, because why means you're going to ask a little bit deeper. You know, you're going to get thoughts from people, you're going to get ideas from people, maybe do some interviews, and you're going to uncover some opinions. Some common methods of qualitative designs include focus groups. You can have individual interviews, just observation. You go out in the field and you do some observation and take some field notes. Okay, the data is usually comprised of interview responses, or like I was saying, field notes. So it's usually these are long narratives, not a lot of statistics. Okay. Then there's quantitative designs. Okay, and they're used to quantify the problem, and you will collect your numerical data, or you will collect maybe some data and you transform it into numbers so that you can run some actual statistical tests. Quantitative data collections methods include all of the fun things the statisticians love. So we would use surveys, maybe short question interviews, big, huge longitudinal data sets, sometimes systematic tests and measurements. Maybe if you're running a clinical trial, you're checking cholesterol levels, things like that. That's quantitative measurements, things that you've measured and you assign numbers to, basically. And here are a very short list of some types of research designs, and I put them into two columns. So you have some qualitative ones on the left side, you have some quantitative designs on the right side. If you look at the qualitative action research, that's kind of close to a quantitative, because what you're going to do is you're going to a lot of times do some kind of implementation of some kind of new program or some new process of doing things, and you're going to kind of follow it and see if there's any changes over time. Case studies, that could be one person you're following, maybe a particular case, some kind of rare, maybe a person that has some kind of rare condition, or a case could be it doesn't have to be a person. It could be a program, again. It could be a group of people. Narrative basically is what it is, narrative. Grounded theory is, that's a really, really interesting one. What you're doing is you're setting up your study. You're taking a lot of commentary, information, collecting a lot of evidence, and then you're trying to come up with a theory. And that's a very, very involved study. I can never say that word. Phenomenology. That's lived experiences of people. What you'll do, that this is one of my favorite ones, and this is the one that you'll see quite a bit. You will maybe take 10 people, interview them with a set of maybe 10 interview questions, or maybe even a focus group, and ask them some questions, and then you'll take their lived experiences and beliefs, and then you'll build your study around that. Historical, I never see that too much, but it's basically you take historical information and you archival information maybe, and you build a study around it. And ethnography is where you actually might go and follow some people around. You're kind of involved in their environment and you take your information. That's a very big observational kind of study that you would do. Quantitative, we have our descriptive studies where it's just basically straight numbers. You have cross-sectional. Cross-sectional, what that really means is that you're taking information from people at one point in time. You'll see this a lot when you take a survey. You're going to go out and you're going to survey some people. Well, maybe you're going to survey a group of people that come into the study over a month or two, but that's it. So it's cross-sectional. You're just taking that cross-section of people at that certain point in time, and you're taking a survey, and that's what, and then you're coming up with your information. Quasi-experimental is not experimental. It's instead of randomizing people into two groups like you would in a true experimental study, what you would be doing is they come in already assigned more or less. The quasi-experimental and causal comparative are very much the same. And an example would be if you're looking at gender. Well, you're already a male or female, so you can't be randomly assigned. So it's experimental except for the point that the groups are already there. Meta-analysis is very, very involved, very interesting, but what you do is you take all the literature that you can find that's out there that serves your problem and your purpose, and you sort through it, and you try to find this overarching kind of means or standard deviations or some kind of statistics that represent the literature that you've looked at. Cohort studies and longitudinal studies are very, very much they deal with larger databases usually. Cohorts might be if you're in a school system and you're looking at some kind of, you're looking at groups of students over 3 years, but they're not necessarily the same students. Okay, so they might be students come and go, right? They enroll, they move away. So you would probably call them cohorts because they're not necessarily the same students. They're just different years. They're in the same program, they're in the same school, but they might be different students. Cohort in yearly cohorts. Longitudinal, though, are the same people. So you'll look at the same people over 3 years, or you look at very large longitudinal studies, maybe look over 10 years, 20 years. Of course, people drop out. And such, there's attrition over time, but basically the difference between cohort and longitudinal is that you follow the same people. I have a note here that a research design in principle can make use of any type of data collection method. So whatever method you want to use, of course, some designs work well with certain methods and you see them more often with certain methods. However, there really, in theory, isn't any methods that says you can only use it with a certain design. So again, I said, think of research design as the logic and methods as the logistics, right? Your tools and how you're going to do it. Okay, so we're going to follow a very simple study as I talk about this a little bit more. It'll help you to maybe understand it a little bit more and get that depth that only you can do in an hour-long webinar. But we'll do our best here. So the steps to design a very simple study. So my study is I want to understand the relationship between the sunrise and crowing roosters. Okay, and we kind of already know that there's a relationship, but we're going to pretend that we're going to pretend we have an idea of it, and we're going to go out and test it. Okay, so our first step when we're designing the study is what is my research question? Okay, so research question defines our choice of the design and all of the next steps. So we really need to know what, and that comes from the problem. What's the problem and what's my question? So here's, depending on our different designs, here's some different ways we could ask our question. Okay, so if we're doing a descriptive design, we're going to do maybe a qualitative kind of method. So why does a rooster crow at sunrise? So we want to get some in-depth information on why is that rooster crowing at sunrise. Correlational design, we would ask, is there an association between the sun rising and roosters crowing? You know, is there something going on there that there's an association? Experimental design would be, does the sunrise cause roosters to crow? Okay, so yeah, as you can see, there's a little bit of a difference there. And you'll see how we set them up according to the questions. Step two, which might be more important than step one, and now we're going to start going into our methods territory. Remember, I said we're going to kind of slide into it. So now we have our research question. So we're going to go from our logic into our logistics. So my suggestion would be to start your literature review before you begin outlining your design. Why? Because you don't want to do something that other people have done over and over again. Yeah, now, typically you don't. I'm all for reproducibility, and I would love to see more studies out there that people do that have been done before, and it's just basically we're trying it again to see if we come out with the same results. I think that's needed very, very much in all fields, but it's very hard to get published if you don't have something original or a little tweak, or and if you're a dissertation student, they're always looking for that gap. So it's a shame. Okay. However, if you have a good argument for doing a reproducible study, that's great, but you might not get published. So it's a good thing to know is have others ask that similar question. Have they focused on a similar concept or theory? If it's exactly the same as what you want to do, you might want to change it up a little bit. What instruments, populations, sample sizes, types of statistical analysis have been used in similar studies? That literature review is going to save you a lot of effort because you're going to be citing some things, this for this study did this and this study did that, and that's why I'm doing this, right? So you always want to have something to back it up. Also, it's if the tool's good, if you see an instrument that's great, that you find it from your literature review from similar studies. Any questions on anything so far?
Yeah, we have Terry that asks, does longitudinal have to do with people? Can you do longitudinal with companies over years?
Yes, you can. I've actually done studies where I've done countries. There's one I have published. In fact, I think it might be one of the first ones I had published way, way long ago, 10 years ago or so. And it was cell phone use and technology use and a number of protests. And it was done over time and over many years, and I think we looked at about 20, 25 countries to see if the number of protests increased over time. So yes, you can definitely do it. Your units of measure don't really matter so much. It doesn't have to be people. Okay, so we've done our literature review. We have our research questions. And so now we want to know how exactly we're going to do it, right? How are we going to answer this? How exactly will I answer my research question? Logistics, right? The research method includes all of the ingredients for our recipe, all the materials and work we need to build from that blueprint that we have. Okay, so where it's going to include data collection. How are we going to collect the data? Are we going to use surveys? Are we going to find an archival data set? Are there some records somewhere we can use? Are we going to do interviews? How are we going to process it? How are we going to store it? How are we going to clean it up? How are we going to code it? Data, I always say data comes in, it's ugly, it's mean, it's nasty, it's dirty, it always needs cleaned up. So it's always nice to put into your methods, into your plan. How are you going to code it? Are you going to code males as 0, females 1? If you do regression, that would be the way to do it. If you do an ANOVA model, you might code them 1 and 2. So really, these are things that you really want to think through and think out. How are you going to summarize the data? How are you, a lot of times in a statistical analysis plan for clinical research, you have tables and figures. You have a list of tables and figures that are kind of dummy tables or mock tables. You don't really have the numbers in them yet. You have made up numbers, but it's great because you can take a look at those tables and it helps you to think ahead of how I'm going to structure this. How am I going to show my information? And things always change, your best laid plans. So keep that in mind too. However, it's always good to start with the plan and then you just talk about what your deviations were once you collect the data and clean it up and find some new problems to deal with. But then you also want to talk, how are you going to analyze data? What kind of tests are you going to use? And then of course you want to how do you plan on interpreting the findings? What are you looking for? And how do you want to maybe present that? So over here on the right-hand side, the statistical analysis plan is often what we use in a clinical research to detail this design and method. In a dissertation, your methods are usually your third chapter, and your results are usually your fourth chapter. So we're in methods territory now. We're planning it. We haven't analyzed it yet. So that would be some things we need to think about now. We're talking about methods. What kind of information can you get? Okay, definitely important to know. It's great to have a great idea and that you want to study something. You have your problem, you have your research question, but you have no way of getting that information. Then you won't be able to do the study. So again, the literature review is great. What tools and instruments are available? If you're going to collect data with a survey, or you're going to use a database. If you do use your own survey, or if you use a survey, let me put it this way: if you use a survey, find one that's out there. Get permission from the author to use it. Usually they're very, very happy to let you use it as long as you acknowledge them and give them proper credit in your work. Some surveys are proprietary and they want you to pay for them. Which it can be done, but oftentimes you can find one that's free to use, or you can get author's permission. So feel free to reach out to the people that have developed these tools and tell them about your study and what you plan on doing, and they're usually more than happy to let you use it, or even adapt it. And just let them know you plan on adapting it and how you plan on doing that. And then if you do adapt it, there's some checks and such you would want to do, but that's again another webinar. But maybe one day we'll do one on validity and reliability. But again, if you develop your own tool, you're going to have to do all these checks yourself. Dissertations are done on developing tools, but if you want to do an actual research, try to avoid developing your own tool unless you absolutely must do so. It's going to save you a lot of time, a lot of headaches. Okay, so what kind of information can I get? We're still thinking about this. How are we going to review and analyze that data? Are we going to have hypotheses to test? If you have a qualitative study, typically you only have research questions. You don't test hypotheses. Hypothesis tests, of course, you have to have a statistical test, right? So you're going to use more of a quantitative kind of design. So that'd be something to think about. Am I going to be collecting data and testing hypotheses with a statistical test? And what test should I use? Oh, and boy, this is a big question. The options are many. Here's an example I stole from Penn State Stat 500 website. These are all different quantitative tests. There's a place, where do you start? Let's see, I think we would start right here. Do you want to estimate a value, test a hypothesis, examine a relationship? So you go from here. Do you want to try to find maybe a mean or something, go more of a descriptive route? Here we go. We'll follow these threads here. If you want to examine a relationship, now we're looking at, okay, this is more of maybe that correlational design, right? So do we have quantitative or categorical variables? Quantitative basically are like a continuous type of variable: height, weight, time, BMI, things like that. Categorical are just like it sounds, they're categorical. They're also called nominal. Ethnicity, gender, things that can't be ordered. Some people will say that ordinal are categorical also. So again, the one thing about statistics, and I always joke about, one of my favorite things to say is statisticians have three to five names for every concept there is. And the reason that is because we do work in so many different backyards and so many different fields of study, and each field of study has their own way of saying and looking at things, their own nomenclature. So it can get really, really crazy. But basically, you need to think about this. If you're going to be using statistics and testing a hypothesis, what are some of the what way should I go with this? A t-test would compare two groups, an ANOVA would compare more than three groups, and it's comparing on mean scores. So if you want to compare medians, there's different tests. So again, boy, this is many webinars here. However, you need to figure that out. How am I going to test this? What analysis am I going to use? So I can spend a little bit of time on this if anybody has any questions.
No questions.
Okay. If any come to you, just let me know.
No problem.
Okay. Okay, so step 5, we're going to develop our hypotheses. We decided we needed them, okay? We're using a quantitative study. I want some hypotheses. So these are statements that you make to test your research question, okay? So we word them to fit the tools that we're going to be using. So if we're using, for instance, correlational design, we would, in our hypotheses, we would say something like, is there, or basically it's not is there, it's not a question, it's a statement. So you would say, for the null hypothesis, there's no difference between gender and well-being scores. Okay, or your alternative hypothesis would be there is an association between gender and well-being scores. If you had a comparative study, then it would be, do males and females different on the mean of their well-being scores? Okay, so now we're asking if there's differences and you're doing a comparison. So definitely, depending on your test, your hypotheses are going to be different. The null hypothesis means no effect. Null means none, nada. So this is the hypothesis that states there's no difference. That's the hypothesis we're testing. We're testing for no difference. Okay. The alternative hypothesis is what we want, right? It's what we want to see. We want to see a difference between genders, maybe on well-being, or we want to see an association between roosters crowing and the sun rising. So that's going to be our alternative. And as I'm saying down here at the bottom, is the confusing thing is that we will draw our confusions, our confusions, yes. We're going to draw our conclusions too, and our confusions based on the null hypothesis. I'll tell you, when I was an undergrad, I don't think it was until my junior year that I really, really wrapped my head around that we test a null hypothesis. It just drove me crazy that it just didn't make sense. But we'll talk about it a little bit more later. I'm going to go through to 3 different designs and kind of show you how we set them up, these questions. So let's start with the descriptive research. Okay, like I was saying, this is mostly your qualitative kind of thing. You can use it in a quantitative study, but typically descriptive, I always associate it with the qualitative. We're going to get that why. We're trying to get that depth of meaning. We're trying to dig down deep. So it consists of only the research question, no hypotheses. And it's because it's descriptive and we're not testing anything, right? So descriptive studies can be both quantitative and qualitative. For a quantitative, an example, I gave that naturalistic observational study, and a researcher would ask, what proportions of roosters crow at sunrise? And then she would visit a farm each morning at sunrise and she'd count them, maybe tally them. Every time the roosters crowed, she'd make a little check mark. And perhaps she notes the time they crow, how long they crow, and she might also she might want to control for weather conditions. Maybe if it's sunny out, they crow more. Right? If it's cloudy out, it might be lighter out, but maybe they don't crow as much. Maybe the brightness of the sun might have some kind of effect. So that might be something you want to control for in your study. For qualitative, there's many types of qualitative studies. As I'm saying here, too many to cover individually, but in general, it's an observational study and the goal of obtaining a deeper understanding. So the researcher would ask, why does a rooster crow at sunrise? It's so philosophical, isn't it? Why do they crow? And she can't interview the roosters, but she can ask a group of chicken farmers. Maybe she has 10 open-ended questions, and she's going to ask them about their thoughts and beliefs on the phenomena. So her studies actually would be about the farmers' perceptions of why roosters crow, not actually strictly about the roosters. So she's adding in that element of the farmers. Okay, that's pretty cut and dry. Correlational. Correlational research usually have the words relationship or association. Predict is often used if there's a regression. You'll have predictors and you'll have criterion. And criterion is your dependent variable or your outcome. Again, we have to have three names at least for everything, right? So in a regression model, the dependent variable is also the criterion and it's also the outcome. Okay, probably another name or two also. But our research question for correlational design on the roosters and sunrise would be, is there an association between the sun rising and roosters crowing? Then my null hypothesis is going to be there's not a statistically significant correlation between the sun rising and roosters crowing. The alternative would be there is a statistically significant correlation between them. So my researcher now, she's measuring if the sun rises each day, okay, and she's going to code it, see, because she's going to operationalize things, and this is part of the methods. You want to make sure you detail it as much as you can. She's going to code it 1 if the sun rises, and she's going to code the day as 0 for if it's cloudy, rainy, anything where it doesn't rise and shine, okay. The researcher's also going to measure if the roosters crow within a 5-minute time interval after the scheduled sunrise, and then she's going to also code those. Um, each rooster is 1 for yes, a 0 for no. So each rooster, she's going to see if they crow. And then she's going to get her sunrise schedule from the Farmer's Almanac, right? So, I mean, it's definitely going to be much more detailed than this, but as you can see, it kind of gives you an idea of a lot of times when you're designing a study, you'll ask a question and it just makes you ask 5 more. Okay, so it's like, okay, I want to test the association between these two things. How am I going to do it? What tool am I going to use? How am I going to code it? What kind of metrics am I going to use? What kind of, if you're doing some kind of clinical research and you're using some instruments, how are they calibrated? Have they been validated? There's so many things you want to check into. What's the standard that people use? That's also a good one. If there's a standard reference like a farmer's almanac, do you have to make adjustments for your time zone, right? So lots of things to think about. But that would be how you would maybe set it up for a correlational design. So the researcher, she's going to perform a correlational analysis. In this case, we're going to make it a phi correlation because both variable responses are dichotomous, yes or no. Okay, and no was coded as 0, 1 was coded as yes. So researcher finds a strong and direct correlation between sunrise and roosters crowing. Okay, so strong and direct means that they're very much associated, and when the sun rises, the roosters crow. When the sun doesn't rise, the roosters don't crow. So they're kind of moving in a like manner. Okay, but wait, remember what your intro to statistics professor always said to never forget. Correlation does not imply causation, right? The sun and the rooster correlational study. I love this. I think this is a great concept for trying to understand the correlation and causation. So you might have significant correlation, and boy, there's an association. Let's say that it was a correlation of 0.8, which is very, very strong. P-value is less than 0.05, so it's significant. We're happy. Great correlational association. Everyone knows the sunrise is related to rooster crowing. Everybody knows that. However, the rooster's crowing did not cause the sun to rise. Okay, therefore, you can't say that they did that. However, everyone knows the sunrise doesn't cause a rooster to crow, but it does, right? It does cause a rooster to crow. And that can be tested with an experimental design, which I'll show you next. But any questions on the correlation causation thing? I know sometimes a lot of people get confused on that.
We have Jesse asking,
Mm-hmm.
so when you don't really know, this is basically how you write the hypothesis, or if you have a guess, do you phrase it differently? Then it goes on, don't really know what the answer might be.
Yeah, if you don't know what the answer might be, now you're going into an exploratory study. And something like that, I like to refer to them sometimes as fishing expeditions, because you're going in, you say, maybe I have some data here. I just want to look at it and see what's going to happen. Well, if I'll look at it this way, now I'll look at it that way. So you really do want to have a design and a plan to really keep it a good scientific type of study in accordance with the scientific method. And that means that you need to have some kind of a hypothesis. You need to typically, whenever you're doing a study, you already have an idea in your mind of what you think would happen, and that's what you're testing. Otherwise, you're in exploratory. Yeah, typically with a scientific method, you're going to have your alternative hypothesis is basically going to be what you're thinking is going to happen. And your null is saying it's not going to happen, right? So it's basically, it's this I wouldn't say a trade-off, but it's almost like a tug of war, right? You have the null hypothesis saying you're testing for it not to be no effect. You're testing for it not to be seen, but you're really hoping that it is. And so you do go into most scientific research, you're going to go into it with some kind of a priori idea of what you think is going to happen. So, yeah, so correlation does not imply causation. So if you want to do something that's going to show some kind of causation, you need to do experimental design. Okay. So how does one show what we already know in this case? That the sun causes the roosters to crow, right? We know this. So you wouldn't really be testing for this, but like I said, I'm keeping it simple, so I thought this would be a good example. The experimental design is the gold standard. Okay, it's the only type of design in which one can claim cause and effect. An experimental design, it has internal validity at its core, which means that if a manipulation is performed, then the outcome happens. And if a manipulation is not performed, then the outcome does not happen. I'm going to talk a little bit right here about deterministic and probabilistic type of approaches to to logic, to a problem. Deterministic is basically that: if A, then B, and always if A, then B. Okay, if A, then B, then C, always that way, right? So if and then A goes to B, goes to C, that means B still goes to C. It's very deterministic. It's set in stone. Research isn't like that. The world isn't usually like that. Very, very rarely are you going to find something that's that logically in step. So we have probabilistic, and that's where you're going to take into consideration, yes, maybe with this group of people it's true, but might not be true for other groups of people, might not even be true for a different sample. Okay, so that's why we always have to test and retest, and you find some conclusions in one study, the next study they might not hold up. Okay, that's a whole part of the scientific method, and there's a paper at the end of this I'll refer you to that you can read a little bit more about deterministic versus probabilistic. But if it was that as easy as 1, 2, 3, step, step, step in everything in the world, I probably wouldn't need to do as much as I do. Okay. But for an experimental design, if you if you randomize people, for instance, into two groups, treatment versus a placebo, okay, one's going to get the treatment, the other one's going to get some kind of sham or placebo. Um, what that does with the randomization as they come into the study, into the two groups, is that it helps you to control for anything that might be different, any of those probabilistic outcomes where, because it's not deterministic, because it's not set in stone. So it helps you control for every other thing that you can think of or things that you haven't thought of, and it kind of washes everything out. You're randomizing, so it kind of takes all those differences out of the picture, so you can just look at the two different treatments or the treatment placebo and then check for those effects. It's going to make it so the effects are for what you're testing for. And that's why an experimental design is the gold standard. Okay, so as I'm saying here, the outcome could be an improvement in change in health, could be test scores, could be a change in appetite, any other measurable factor observed when a treatment or intervention is performed on one group, but not on the other group. Okay, and there can be more than two groups, but we're only going to use two in our example. Okay, one caveat is that the two groups must be as similar as possible prior to the treatment or intervention, and that's why we do the random sampling. That helps to even the playing field for everybody into two groups. Okay. And again, randomization is such as maybe something for another webinar. We can talk a little bit more about it. So here's our research question. Does the sunrise cause roosters to crow? And our null hypothesis is that there's not a statistically significant difference in crowing frequency between roosters who see the sunrise and roosters who do not see the sunrise. So we're going to say there's no difference. The sun doesn't make any difference, or either they crow the same amount, or we're assuming they're going to crow because roosters crow, right? So we're going to basically think, okay, well, the ones that see the sun don't crow any more than the ones that don't. Okay. The alternative would be that there is a statistically significant difference in the frequency of crowing between roosters who see the sunrise and roosters who do not see the sunrise. Here, if I have some really, really picky statistics people in the audience today, this is a two-sided hypothesis, right? You might want to make it a one-sided where you would say, oh, do roosters who see the sun crow more? Significantly more than the other ones, and then you would have a different type of one-sided hypotheses. But on this, we're just going to say, is there a difference? We just want to know if there's any difference. Okay, so we're going to test for that. So here I'm going to have some inclusion and exclusion criteria, and actually we would want them for any study. You want to think about who are you going to include, and are there some things or some types of people or some types of sampling units that you don't want to include, and why. So for your inclusion, we're going to have male chickens, okay, because they're the ones that crow, and they're going to be over 1 year old, okay, and they have good eyesight so they can see the sunrise. And they have a demonstrated ability to crow. We know they're able. There's not something wrong with them where they can't crow. I don't know how we're going to test their eyesight. That would be something to think about. But yeah, so we want to make sure that they can see the sun, right? So these are things that, like I said, it's kind of silly, but it kind of gets the point across, and that's why I chose this one. Um, but that'd be something that maybe I'll think about that this afternoon. How would I test a rooster's eyesight? So the exclusion would be female chickens, right? Because they might crow a little bit. They're not going to crow like a rooster at the sun. At least we don't think they will. Chickens less than 1 year of age, right? Little peeps. We don't want little peeps, and we don't want roosters who aren't don't see well. Again, I don't know how we're going to test that, but we'll figure that out. And they're, like I said, they're important to all research designs. Okay, so always make sure you have that in there. So the researcher recruits some roosters who meet the eligibility criteria from various farms located in the area, has them sign a release. No, she doesn't, but maybe she has to check with the farmers before she goes and recruits the rooster. So she'll have them sign a release saying she's allowed to go and collect some roosters from them. And as each rooster comes into the study, she's going to randomize them. She's going to put them in either in an intervention or a control group. So the intervention basically is going to be the sunrise group. Controls are going to be the ones who don't see the sun. So she's going to randomize them. So she's going to get her roosters, and she's going to just, as they come in, she has a randomization schedule. And she goes, okay, this rooster is going to go to group A, the next rooster is going to group A, the next group's going to B. And it's not A, B, A, B, A, B. Okay, it depends on what your randomization schema says. And so you're going to go ahead and allocate them in. So the intervention group are the ones that are going to see the sun. So during the evening, they're going to be placed into a pen with an opening on the top, and it's going to allow the sun to shine through in the morning. Okay, and then for the control group, during the evening, she's going to put the roosters to sleep into a pen without an opening on the top, so no sun is going to shine through in the morning. Okay, and except for the pen assignment in the evening, whether they're going to go into the open top or the closed top, the roosters are free to go about their day, and they're, I guess, in a communal area. I put them, they get to hang out together. They get to eat the same food. They're going to exercise the same amount. So you're not going to have some in a bigger pen that are out running around free range and the other ones in little cages. You don't want to do that. You want them basically to have everything the same except for that pen assignment in the evening. Okay. And you want them to have the same social interactions, things like that. I can't believe I sat and thought this all out. It's kind of fun though. So the researcher could have exerted much more control in the study and just placed one group of roosters in the sunny pen and the other group in the dark pen 24 hours a day, but she's a kind researcher and ethical to animals. So yes, that's a limitation of the study, is that she didn't confine them 24 hours a day for like a week into their pens. And a limitation, it is a limitation because maybe a rooster gets out and runs away. Maybe maybe there's some things that can happen when they're out and about in the daytime that's to some of them and not the others. So it is kind of messing with your strict randomization a little bit, but all research is give and take, and you have to think about ethical considerations, especially in clinical research. So the patient matters the most. Okay, so you want their comfort. You want them to, you don't want to hurt them in any way, physically, emotionally. You don't want to cause them any kind of stress. So sometimes there's some limitations you have to put into you have to allow your study to have limitations so that you're not doing draconian things to people or roosters. Okay. So each morning, the researcher notes the number of roosters who crowed in each of the two groups during the 10 minutes after sunrise. And again, she's computed that from her farmer's almanac. So she has checks in place to make sure she accurately counts all of their crows. Now, this is going to be hard to do because she has two pens of crows, right? So she might need a helper. Okay. She also might want to audio tape, okay, as she's doing it, just as a backup. So it's good to, again, put these kind of things in your plan. Think it through. Be holistic about it. Um, the thing about when you're doing these kind of things too, time and money. Okay, there's a time and there's a temporal and monetary cost of running a study. It's a big deal. Okay, so simple tape recorder, a tape recorder. Okay, I guess audio recorder now. I guess we don't have tape anymore. I'm showing my age. But the simple tape recorder could be less expensive than a helper, right? But using a recorder can add time to the process because now the researcher has to listen to the recording, match up her tallies to her crow counts. And she can have both. She could have a helper and a recorder. But again, you kind of need to think about time and money because you don't want to go too far with all the checks and balances. Like I said, all studies have limitations, and you're just going to have to accept that. That you don't want to have glaring limitations that are going to invalidate things. But it might be that. In this case, a helper and a recorder, that's fine, but you don't really, do you need 5 people out there? Probably not. Okay. So after 1 month, oh boy, she did it for a month. Okay, so she compares the number of crows that were emitted at sunrise for each of the 2 groups of roosters. Okay, and she compares these findings. Okay, and she determines that the roosters that saw the sunrise crowed significantly more than the roosters who did not see the sunrise. And now she has an experimental study with good conclusions, and it's generalizable. Okay, and let's revisit that. So since her design was randomized and controlled, she can potentially generalize her findings to similar types of roosters that did not come from the farms where she collected her current sample. Okay, it must be randomized in order to even attempt to claim generalizability, and it might not be so easy. Okay, what if the researcher only used one breed of rooster? Okay, could the findings be different if she sampled from farms in another part of the world? And this is where repeatability is going to come in handy. It's important to make sure you cover all the bases you can. Okay, it seems overwhelming. Think of the big picture, but do it in little steps, right? Step by step. Okay, some more about methods. Methods are the roadmap of repeatability. Operationalize your variables. How are you going to code them? Are you going to code males as 1 and females as 2? Are you going to code them 0, 1? How are you going to code ethnicity? Are you going to use dummy codes where each ethnicity is a variable? Or are you going to make them white 1, African American 2, Asian 3? How are you going to do that? And that depends on the test you're going to use. Okay, so but it's always good to get those operationalized, get an idea. When you're doing that, when you're thinking it through like this, it's going to help you to see some problems. And like I said, for each question you ask, you might have 5 more, but these are questions that you want to think through before you pull your data and have an oh no moment where you go, oh no, I should have, right? You don't want to do that. You're going to do it probably anyway. Because no study's perfect, or something will happen that you didn't plan for, or you could have planned for it and something totally different that you would never even see happening could happen. So, but you want to minimize those oh no moments, right? So yeah, determine those analyses. Have a backup plan. What if you want to use, say, an ANOVA, and you have your normality is not really a big deal. They'll tell you that in school, but say your variances aren't equal. Okay, that's a big deal. Are you going to transform your data? What if transformation doesn't work? What if it makes it worse? Maybe there's a non-parametric technique you could use where you don't need that normal distribution. You don't really need the equal variances. Maybe a Kruskal-Wallis test. So you want to have that backup, right? Kind of have a plan B. Okay, think about possible control variables. Okay, so the big 5 for many studies are age, gender, race, ethnicity, SES, which is socioeconomic status, and marital status. Of course, roosters might have other control criteria, right? Maybe age, maybe breed. So maybe you want to put into your model the age of the roosters, maybe control for those. Maybe if you did have different breeds, you want to make a variable a breed type, or maybe a few. Probably it depends on your study. But you might want to incorporate the breed of rooster in there, because maybe some breed of roosters, they just crow more. Maybe some breeds of roosters don't crow much at all. I don't know much about roosters, but that'd be something to think about something to search the literature about, something to ask the farmers about, right? So there are numerous methods for collecting data and crunching numbers. Okay, so for the most part, methods of sampling and analysis, they're interchangeable between qualitative studies, and I think I covered that before. So a certain type of study, a certain like a causal comparative, you could use many different types of tools. You could even use a survey. You don't have to just use that for correlational. Okay. Here's some references. The first one is organizing your social sciences research paper, which is it's a very good one. And it has some different quantitative. I think it's mostly quantitative designs. Kind of gives you a little bit of information on it. There's a paper on experimentation, which is very informative. The third one, that's the one I was talking about, where the deterministic versus probabilistic, and the intricacies of research design. Very good paper to read. I would suggest reading that. And then some good books by Tabachnik and Fidel on experimental design and multivariate statistics, which probably it has all kinds of different methods and designs in there. So some very, very good references there. So I'm basically done. So thank you for attending. Here's all of my contact information. I will be sending a handout, and I will be sending this recording out as soon as Mr. Rod Eisenbeisz puts together the nice, pretty recording, takes out all of my pauses, and you can leave a couple of giggles in, Rod, and don't clean it up too much. But I'll get that sent off. And I think the next webinar is going to be in February. I have them every quarter. I think the next one I'm going to do is on power analysis, but and that's for sample size, because I think that'd be the next step for all of us that are following along here. We've done the literature review. Now we've done some design and methods information. Let's talk about how big of a sample you need next, I think, in February. And of course, if you have any ideas, love to hear it. I would love to do some webinars for what you guys want, because that's why I'm doing it, right? To help out here, to give you guys some information. And so that is it for the presentation. So I'm open to questions, and boy, we have some time. So if anybody has any questions, let's ask.
One question is, how important is it to have a random sample?
If you want to talk about generalizability, it's very important. And it doesn't you don't necessarily have to pool the sample randomly. There's random samples, and then there's randomization. Random sample is basically you take a list of your population. Say you have a list of people, let's make it easy, in a geographic area. Say I'm in Murrieta, California. So I have a list of everybody that lives in Murrieta. And well, we don't want everybody. Let's just have some inclusion criteria, right? I just want all the women that are between 30 and 40 in Murrieta, and I'm going to ask them some questions on a survey. Okay. No, that's a correlational design. Let's say I'm going to ask them, I'm going to have them try some kind of program, maybe an exercise program. Okay. They're 30 to 40 years old. They live in Murrieta. I'm going to try the Murrieta diet plan. Okay. So I'm going to take them off this list, and I'm just going to randomize them off a list. Right? I'm just going to randomly sample them from a list, and I'm just going to go, okay, the ones that are on my schema here, I'm just going to pull them off the list. I'm not even going to tell them, not even going to ask if they want to be in the study. They're just randomized, show up, take the diet or not, right? So you're going to be one or the other, automatically randomized. That usually doesn't happen. In the work I do, a lot of times I do a lot of cancer research, and the patient already knows they have cancer. They're coming into the study, and they're going to be randomized. Okay, so you can't give people a disease, so you have to take them as they come, and then you randomize them into the treatment or the type of treatment they're going to have. And a lot of times, especially with the cancer studies, they have a preference for treatment. And you have to take that into account also. So that kind of messes up your randomization. So you will have some people that they don't care. They're happy to be randomized. And then you have some people that really care, or maybe their doctors care. They want them to have this certain treatment. So you have to, then those patients you can't use in your generalizability. You can only use the ones that agreed to be randomized. So it gets very complicated, but those are some examples.
Martin asks, if experimental design is gold standard but not possible in certain situations, are there steps researchers can take to make correlational designs more robust, if not as robust as experimental?
If you're talking in terms of generalizability, which is what everybody wants to do, like, oh, I did a correlational study, and not only is it good for the students in the school that I looked at, all ninth grade students in the state, will this will apply to. You can't really do that with a correlational type of study or any kind of convenience sample kind of study, right? So the best thing you can do is that repeatability. Have that study repeated over and over with different groups of students in different schools. Maybe you have the ninth graders in this school and this state, and maybe now we want to go to California and test the ninth graders in this certain school, maybe a similar school. It's just the only way you can really, really get that to be more generalizable is just with the repeated testing.
Jesse asks,
Mm-hmm.
do you have tips for finding existing survey instruments when you know you are doing a survey? And Martin says thank you.
Oh, you're welcome, Martin. Okay, so tips for finding particular surveys?
Existing survey instruments
Mm-hmm.
when you know you are doing a survey.
Okay. There are some Google. Google's your friend. First of all, the literature review. When you're doing your literature review, because first of all, like I said, you don't want to do a study that's already been done before. So, and you also want to see what has been done before. So your first step is that literature review. And as you do that and you look through your journal articles, you're going to see what instruments they might have used. Okay. The other thing you can do is Google and emotional intelligence, for instance. I had one I had to try to find emotional intelligence. It was actually soft skills, which is very closely related to emotional intelligence. So I looked up, I Googled soft skills, emotional intelligence, things like that, and I kind of narrowed it down to find a couple tools that way. But really, the literature, Google, and just maybe look at PubMed, some of the databases, and maybe try to again look at the literature for some tools. If you are in a field where your colleagues are very knowledgeable of the type of research you're doing, they might have some ideas. So it's basically you got to research, right? You got to be a detective and try to find it that way. As far as there's databases all over the place, and you can just type in. I mean, there's depending on what your study is about. A lot of times the data has been collected in large database. There's NHANES, there's all kinds of CDC databases. I found one on Ebola. I'm working on an Ebola study that the World Health Organization had. So some of these big organizations, Census Bureau, they keep data, and a lot of times you can get some permissions to use the data. But yeah, for instruments, try not to design one yourself. Try to find one that you can adapt, and Google and the literature is probably your best bet.
Jesse asks, but you don't have to do the full validation step if you find something?
It depends. If it's a tried and true Rosenberg self-esteem scale, been used for years. It's been used in thousands of studies. The only thing I would I wouldn't check validity with that because it's been validated so much. But of course, when you're writing your methods, you want to talk about all the studies where it's been, not every single one, but many of the studies where it's been validated in studies that are similar to the ones that you're using, right? If it's a survey you're using that's never been used in a study like yours, then definitely you want to try to do some more checks on it. Typically, though, whenever I get a survey that's been tried and true, when it comes time to do the analysis, I'll do, if it's a Likert or Likert kind of scale, I'll do Cronbach's alpha, and that helps with the internal consistency, reliability. And what that means, the Cronbach's alpha and internal consistency reliability means that you're testing to see if that survey holds up with the sample of people you collect with their answers, right? So you say you pull a sample of 100 people, you're using Rosenberg's self-esteem scale, and so you want to do a Cronbach's alpha to make sure that each person is kind of, if they have high esteem, that they're answering kind of up on a high across the board. If it's a person with low self-esteem, you would expect a lot of ones and twos, lower scores, and so you want to make sure that each person is consistent, and that's what Cronbach's alpha does, and that's a test of reliability. But if it's a tried and true instrument, the validity checks can, the divergent and convergent validity, all of that is usually done. And that's why I say try to get a tried and true one. Don't try to develop it yourself, because otherwise, then you got to do your validity, reliability, the convergent, divergent, all that. It gets crazy. Test, retest, pilot, So does that answer it, Jesse, for you?
Jesse didn't respond, but Terry asks, so did you say you use research questions when you do qualitative research, but hypothesis when you do quantitative research? It seems like they are mixed in the literature review.
Typically, that's the way it is, Terry. Yes, you would use only research questions for a qualitative, okay? Because the hypothesis, statistical hypothesis, you're testing hypotheses, right? So that means you're going to be using a test. You're going to use a t-test, ANOVA, regression, any number of statistical tests. So therefore, you need a hypothesis. Statistical tests are usually done with data. So you have a quantitative study that's using data to test hypotheses with an actual test. Qualitative, on the other hand, a lot of times it's just interviews. Maybe you talk to 10 people about their thoughts on a new program on TV or something. It won't be like that. It'll be something more than that. But so you have a group of 10 people. They're in an IT department, and they have a new computer system. What do they like about it? What don't they like about it? How do they feel about it? Why? That's a qualitative type of study. So you're not testing anything. You're not using a statistical test. You're just giving some descriptive information, a lot of narrative, and coming into some thematic, some themes like, oh, they really like the user interface. They hated the colors, things like that. So no, you wouldn't need a hypothesis for a qualitative. There are mixed methods studies where you have both, where you will have a qualitative element, and then maybe you will do some hypothesis testing of some kind of of another element of it. Then yes, you would have both. That's called a mixed methods design. When you put both together. But typically, yes, qualitative research question, quantitative research question, and hypotheses, because you have a test.
Terry says, perfect. That makes it much clearer.
Yay.
When I see a hypothesis versus not.
Mm-hmm. Yeah.
Another question is, how big of a sample do I need? What is a sufficiently large sample?
That's a very good question, and it's so dependent on so many things. I am going to do in February. I will do the power analysis, and that's what it's about, sample size, and so we'll cover it then. But it depends on the test you're using. If you're using and it depends on how big of a difference you're looking for between groups, or what your effect is. There's something called an effect size. It's like how big of a difference are you looking for? Or how big of an association, right? If you're testing to have a very strong association between two variables, then you're going to need a different sample size. And if you're testing to maybe say that, oh, if I have a correlation of like 0.2, you're going to need a lot bigger sample. So typically, if you're looking for big differences, you need smaller samples. If you're looking for teeny tiny little differences between groups, like say a mean difference of 2 points on a 100-point scale, then you're going to need a pretty large sample. So there's 4 things that are involved in getting the sample size. There's a mnemonic. It's called BEAN. Let me see if I can remember. You have to have your B is for your beta, which is your power. You're going to need, so typically that's like a 0.8, 80%. E is for your effect size. How big of a difference do you want to see? A is your alpha level, which is usually that 0.05, that p value you're looking for, which is 0.05. And N is your sample size. So if you know 3, you can figure out the last one. So in the power analysis webinar, and actually I do also have a power analysis on the YouTube channel or on the website. If you go to the website, the webinar page, there's an older one of power analysis. Look that over, and that'll give you some idea. And then we'll do it again in February and answer some more questions and get maybe dig a little deeper into it.
Another question is, can I have more than one design in my study? What if I have more than one research question?
You can have yes, you can have more than one design. You can have both the qualitative and the qualitative and quantitative methods. So you can typically you can have more than one design, but I typically would say try not to try because here's the thing: as you go through your research, as you set things up, you're going to probably have to make it smaller, right? You probably, when you first start out, you have big ideas. I'm going to test everybody in the United States to see how they feel about, see how relationships, how marriages that have been around for 20 years, what are some of the things that keep them together? Oh my gosh, that is so huge, right? So you want to bring it down to maybe, people that have been married over 20 years, maybe give them a survey of some kind of how well do they know each other, something like that, and pare it down a little bit. Yeah. So, but yes, you could possibly have a couple different designs. You definitely can have more than one research question. Okay, but again, if you're doing a dissertation research, I would probably try to maybe have an overarching research question and then have a couple hypotheses to address that research question, a couple statistical hypotheses in a quantitative. In a qualitative, I'd have an overarching research question, which is like related to your problem statement, and then maybe I might have a couple more research questions, sub-research questions, or tinier ones, or more specific. But don't try to make it the end all be all. Research just doesn't hold up well whenever you're looking at a lot of different things at the same time. You want to try to pinpoint it.
All right, and that was the last of the questions.
Was that it? Okay. Well, we did pretty good. Had some time to spare. Well, thank you everybody for coming today. This was really fun. I hope it was informative, and I see the people that came stuck it out. So I'm glad. I'm glad. I always love doing these things, and I'll see you guys in February. And have a great holiday. Oh my gosh, I can't believe it's November already. Have a great holiday season, and to next year we'll keep at it, and we'll move this forward. And have a great afternoon, everybody. Thank you, Rod.
Thank you.
Okay, bye bye.